Thank you. Thank you. Thank you. Thank you. I think I'm gaining mass. Good Spanish food. So, it was important for me to understand, the dynamics of the structure of the vacuum that would produce charge, the dynamics that would produce, angular momentum, spin. But all these were dynamics that you could find, everywhere, meaning from the solution that I was coming up with, was there evidence of it? Now, this would be a black hole. It could be a universe, it could be an atom, a subatomic particle, but I was, defining the structure as a double torus, as we saw, with these dynamics, and the two membrane of the two toruses interact with each other, so that you get wave functions at the equator of the system. And I started to think, there's this problem in physics where Einstein worked on it and Hubble worked on it, like the rings of Saturn, or the rings of Jupiter, why is, dust and matter accumulating at the equator of these planets? Why are planets spinning around the sun at the equator of the sun? Why do you look, when you see a galaxy, you see that most of the density is at the equator of the galaxy, and you get a disk-like structure. It started to make sense now that this would happen, because this would be where matter gets stuck in between there, and now you have a ring and then space and then another ring and then space, or a planet and another planet and another planet, and this is actually the function of space-time creating that horizontal plane. That's a gyroscopic effect of the two torus interacting. So I started to look at cosmological structures, and some, for instance, here is quasars. These are huge vortices that are coming out, these objects. This vortex here, this big spinning vortex, is 10 to the 6 light years. That is, a million light year long vortex. And when they look at it very closely, it seems like it's spinning at the speed of light as it approaches the black hole. So again, we're finding the same dynamics. Now this is a microquasar. Those are found inside galaxy. And again, you get these vortices, but now it's 3 light years long. So, the same dynamics in each fractal function. But when I was looking at all this, I was thinking, well, this is one thing, but actually, let me see. Actually, if you have such dynamics how, in the middle of the double torus is the hole, right? Is the space. Now the space has this function, the vacuum has this function that seems to be stillness, right? This function at the center that is like no movement. So how does all this movement create no movement? Like in the middle of a hurricane, what do you find? You find a hole, right? And in the hole, there's no wind. It's perfectly calm. And then around it is spinning. It can be spinning on hundreds of miles an hour, like at least, in some cases, 100 miles an hour wind, but in the middle is stillness. And, that kind of links with a lot of the ancient culture knowledge. You find that in many different cultures, like stillness at the center of the spin, is at the center of everything. And so I was wondering, okay, well, I have the dynamic part. Where is the stillness part of the equation? What is the geometry of stillness? The geometry of the spin and the dynamics of the double torus is more like the expansion part of the structure. What is the geometry of the collapsing part, the fundamental geometry of the vacuum? And I start to wonder about this. And I realize, well, in some ways, the sphere, right, or the double torus, is the expansion part, then is the most unstable part. So the geometry of the collapse, the geometry of the source of the stillness, must be the most stable geometry, the most compact geometry. I was looking for the geometry of perfect equilibrium. So, let's see. That slide before, at the time, I was studying ancient civilization at the same time as I was studying physics. And I was, looking for information about the geometry. It seemed like all these different civilizations all around the world built similar structures around the world, these pyramidal structure. And I started to wonder, maybe they knew something about the geometry of the vacuum, about the geometry of the structure of space. And I opened this book that was called Mysteries of the Mexican Pyramids by Peter Tompkins. And I opened it so-called randomly, and it opened on this page. Now you remember that I was working with like a sphere and tetrahedrons. Now the tetrahedron is the smallest, most stable geometry of the Platonic solids. So I knew that the tetrahedron may be like a possibility for understanding the structure of the vacuum itself, the structure of stillness. But I knew the geometry had to be perfect equilibrium, so that all the vectors would cancel out in the middle of the torus to create perfect equilibrium, perfect stillness. The part we call the vacuum, that doesn't seem to be anything, but that is actually everything canceling out. Just like the middle of the hurricane. So I looked into it, and when I opened this book, I was surprised to find a tetrahedron in a sphere. And I was thinking, that's very strange, because this is what I had concluded to. So I started to read where this came from in this book. And it was the result of an engineer that spent 20 years studying the ancient city of Titihunacan near Mexico City. And he studied, there's the moon pyramid and the sun pyramid and the way of the dead and all this stuff. And he was doing a survey for the American Society. And so he was surveying, and the same numbers kept coming out. He was trying to figure out these numbers. And he noticed that the buildings were in position to each other so that it would make the solar system map, including Pluto and Neptune, which were not discovered by us until the early 1900s. And then when he continued to look at the math, he realized that they seemed to always come back to the mathematics that describe a tetrahedron in a sphere. And the tetrahedron, if you put one point on the South Pole, for instance, will intersect the sphere on the northern hemisphere at 19.47 latitude. And it has a very specific, very interesting relationship to the sphere. If you put a tetrahedron inside the sphere, it divides it so that the sphere has 2/3 on the bottom and 1/3 on top. If you flip it around, it's the other way around, right? So if there's two tetrahedrons, you would have you have 19.47 north and 19.47 south. So this was very interesting. What I found out later on is that I wonder where that city of Titihunacan was relative to the whole earth. And it turns out, when I looked, that it was actually, let's see, I can animate this. There it is. So, you see, this is that latitude of the tetrahedron. Let me play it again. So, by the way, here's Hawaii. This is actually why I live in Hawaii. And you can see that latitude goes over, let's see if I can rotate it a little more. There's Africa. You can see that it goes over where Mexico City is. And so this is Titihunacan right there. So not only is all the mathematics inside that city, inside that ancient city, telling us about the tetrahedron inside a sphere, but the city itself, on the surface of the earth, is where a tetrahedron intersects the sphere. Now, I thought that was really, amazing. Because you don't expect that from, ancient civilization that's supposed to be not very evolved. Never mind, when you look at the buildings in there and all the mathematics and all the alignments, you realize these people were certainly not savages, right? And so, I started to elaborate on this geometry because I knew that it couldn't be just one tetrahedron. Because one tetrahedron is not equilibrium. In fact, the tetrahedron out of the Platonic solid is very strange. It has two centers. It has a gravitational center and it has a geometric center, which are not in the same place. And so the tetrahedron by itself could not be the geometry of the vacuum only. It had to be more than just a tetrahedron. So I started to work on this. And you know, when I did this, actually, I was living in my van and I didn't have a computer. So I was trying to compute this in my head. So it took a lot of time, and I got a lot of headaches out of it. But, let's see. See if I can start this. I have new animations. Hello. Oh, there it is. Wrong screen. Okay. So here's his one tetrahedron. And, I'm really happy with these new animations. These were done by a company called Gaiam. Gaiam is a large corporation in the United States that distributes DVDs. They distribute more DVDs than Disney at this point. And they are making a DVD about my work that will come out, because the DVDs I sell right now are 8 hours long. So it takes a commitment, right? So they came to me and they said, why don't we make a 2-hour DVD? So we can put it in the Walmarts and, in the Targets and, and all this. So that's on its way. And I got access to their animation bay. And so we did these animation. I'm really excited. These are not published yet. So the animator was having fun here spinning things. And so here, what I found is that this constant that was found in Titiunacan, this constant of, the tetrahedron relationship to the sphere, matched the mathematical constant that Buckminster Fuller. Everybody knows who Buckminster Fuller is? Yes. And so Buckminster Fuller, which I believe was a very great genius, came up with this understanding that tetrahedron was fundamental as well, but he said it's a stack of tetrahedron he called the isotropic vector metric. And he thought it was the mathematical blueprint of creation. So here I'm showing you the isotropic vector metric. So it's 10 tetrahedron on the bottom layer. There's 6 tetrahedron on the second layer. And then there's 3 on the third layer and 1 on top. You get a large tetrahedron out of it. And so I was interested with this because I thought, not only Buckminster Fuller thought it was the fundamental mathematical blueprint of creation, so he somehow kind of figured out that the vacuum geometry might have been tetrahedral in nature. And I think that if he would have spent a little more time with Einstein, he had a meeting with Einstein, but it was only a few hours. I think the two together would have solved unification at the time. But when I looked at it, I said, well, the first thing I wanted to do is take off the tetrahedron to see what was in between. And I removed the tetrahedrons, and now you're seeing the space in between the tetrahedrons. And what's in between the tetrahedrons are octahedrons. You see? And the octahedron just happens to be a pyramid. And that's the thought I had started with. Is like, why did all these people build pyramids all around the world? So I was thinking, now it's like, maybe this is a clue. Maybe they were building pyramids to have a resonating structure interacting with the structure of the vacuum, with the structure of space-time. And, it was really interesting because when I had that first thought, actually, I was in Isla Mujeres, in Mexico, the island of the women. I thought it was a nice name, so I went there. I was single at the time. This is when I was still a ski instructor. And, I had this, I had this schedule where I was teaching skiing in Canada, and then I was teaching skiing in Australia in the summer in Canada and the winter there, and then I was coming back to Canada to teach the winter there, and so I was permanently frozen. And at one point I was like, I need to unfreeze, right? And so I went to Isla Mujeres for a summer to learn to teach scuba diving. And so I was teaching scuba diving, and one day off, I thought, let's go and see the pyramids at Chichen Itza. And so I went to Chichen Itza, and when I arrived there, I was mind blown. I mean, so beautiful, so amazingly perfect. In the middle of the jungle, in the middle of nowhere, And I was sitting on top of the pyramid, and a tour guide came with a bunch of people, and he was telling them how the quarry is like very far away, and they brought the rocks over, and then they, with copper tool and with like vine ropes and rocks, and I was listening to all of that, and it reminded me when I was a kid and I was learning about the pyramids. And I was learning that that was what they were telling us in the schools about how the pyramids were built. It was like hundreds of thousands of slaves with vine ropes and all this. And to me, that didn't sound quite right. So I was really excited when I realized that inside the isotropic vector metric was pyramids. And so I realized as well that there was something strange. When I looked at all the octahedrons in the middle, let's take a look. It's gonna get there. Let's see. Let's make it go a little faster. There you go. In the middle of the octahedron, there was another set of tetrahedrons. Where'd they go? Here they are. And, these were tetrahedrons that didn't belong to the octahedron. They didn't belong to the other tetrahedrons. And they were reverse, pointing down. And they were rotated from the main tetrahedrons. And so there was asymmetry. And I didn't expect asymmetry because the name of the geometry is isotropic vector metric. So isotropic, you expect, isotropic means the same everywhere. So you expect it would have no asymmetry. So I knew this was not complete. It could not be complete because if it was the structure of the vacuum, it would be perfect symmetry. So I was looking for perfect equilibrium, perfect symmetry. So I knew I had to do something about it. So I reconstructed the isotropic vector metric in my mind. I was doing this in my mind, so it was, a little strenuous. But, so one thing I noticed is the universe is polarized. Male, female, white and black. So there must be two isotropic vector metric. And they must be opposite from each other. They must be rotated from each other so that they are polarized. So now I rotated one relative to the other. And now I had two isotropic vector metric. But you see, now I had another problem. It's hard to see, but you see, now I have an egg shape instead of a sphere, instead of a perfect double torus structure. I have an egg shape. So I was like, that doesn't work because the universe makes spheres. So I was thinking, or double toruses. So I'm thinking, well, maybe I need to push one into the other. And that took me a while to figure out, because I didn't want to distort any of the tetrahedrons. I didn't want to have the middle become a big mess. I didn't want to have some weird geometry in the middle that didn't mean anything. But eventually I figured it out in my little head how they would fit into each other. And I went, oh, okay, actually, when you put the two together so that they produce a perfect sphere, the geometries in the middle, the tetrahedrons that were in the middle, that didn't seem to fit in, that was the asymmetry, was actually the tetrahedrons to receive their reverse metric. So that when you push the two together to produce a perfect sphere, the geometry in the middle became, okay, they were having fun with spin. Hello. Oh, there we go. The geometry in the middle became the only geometry in perfect equilibrium. I'm removing the other tetrahedron so you can see what's in the middle. So that, you see, those spaces that were in the middle that were reversed, that I didn't know what they were for, they were there to accept the reverse metric. And when the two polarities came together to produce the perfect boundary condition, right, like the male and female coming together, the geometry resulting in the middle is called a cuboctahedron. And it was nicknamed by Buckminster Fuller as the vector equilibrium. The only geometry in full equilibrium in all vector possibility. Because you see, the vectors to the middle are exactly the same length as the vectors on the edge. So you get perfect equilibrium. There's no other geometry like this. 12 vectors coming together to produce singularity, to produce perfect stillness, perfect equilibrium. You can test this yourself by using your bicycle wheel. If you remove spokes from your bicycle wheel, you can remove spokes all the way down to 12. If you're removing two opposite spokes at the same time every time, you can go all the way down to 12. And at 12 spokes, you can still ride your bicycle. But if you go down to 11, if you go down to 10, anything below 12, then the wheel will collapse if you try to ride it. Right? It's the minimum amount of vectors for perfect equilibrium. And that number 12 is everywhere in many ancient texts. It's actually 12 around 1. 1 being the singularity in the middle, which is 13. Which is a vector that's curled onto itself to infinity. So I was really excited. It was like the polarities coming together to create singularity, to create the new life, to create the new point. It's like the male and female coming together creating the child, right? the singularity, the new life, and the point of absolute stillness. Although children are not quite still. But that's after they come out. I just had a new one 5 months ago, so I know. So, this was all good and dandy, but there was another problem. When I found this, I was very excited. I thought, oh my God, this could be the geometry of the vacuum. This could be the geometry I need to build this technology to reproduce the right dynamics to produce a singularity in space-time. And so, but I had new problems. I had holes up here. You see, some of the faces of the octahedron were covered, completely covered, but some of the faces were uncovered. So I had a new problem. I had a problem of asymmetry once again. And so I knew I wasn't done. I had 2 isotropic vector metric, which is 40 tetrahedrons. And I had to add tetrahedrons to continue to finish the metric. So I had to cover all these faces. And when I covered all the faces, I had added another 24 tetrahedrons to the 40. So 24 plus 40 is 64 tetrahedrons. And when the 64 tetrahedrons came together, all of a sudden I had realized what I had done. I had built a next level vector equilibrium, a next level octahedron on the outside. So the metric was growing in octaves of octahedrons. So it could grow to infinitely big or to infinitely small. To create equilibrium at all levels of interaction. You could build the metrical space a little bit different as well. You could think of it as 8-star tetrahedrons. You see? 8-star tetrahedrons made out of 8 tetrahedrons each that are coming together. And 8-star tetrahedrons, the tetrahedrons are pointing out. It's like the radiative site coming together to produce the collapsing vectors of the vector equilibrium. So the 8 tetrahedrons of the vector equilibriums pointing in. So I had both sides of the equation in the structure of the metric. It all kind of came together in this beautiful way. And I thought, that's it. This has got to be the geometry of the vacuum. The other thing is that it grows in perfect octave, like musical notes. Each next size cube octahedron is half the distance in radius as the original one. So it grows like musical note. It's like the vacuum is like a big musical instrument that seeks, equilibrium at various scales. And so I was very excited about that. I know it might sound strange to you, but it was exciting to me. I thought this has got to be the vacuum structure. Oh, okay, here we go. It must be growing in perfect octave like this to fill the space of all the structure of the universe. And from it, the double torus emerge. Because these structures are collapsible. When you collapse them, they produce a double torus. We eventually wrote the math for this. And it was hard for people to visualize that. So we did a little animation so you can see how the double torus come out of it. Now this is a kind of a rough animation because it's not quite like that. I'm working on a better one to describe it. But here you're going to see the linear geometry of the structure of the vacuum come together to produce the double torus. You see, when they come together, each one producing a torus, now you have the double torus. Here's the 24 other tetrahedrons. And here we're going to roughly show how the geometry actually rotates to collapse to produce the dynamics, the spin of the double torus. And here we are representing the matter production that's occurring at the center of the system. You see, in this understanding where the vacuum is the source of creation, matter creation didn't just happen in one big bang, so long ago, but it actually is occurring all the time. Matter is being produced all the time in our universe. This is why we are expanding and accelerating. Our universe is accelerating this constant matter production because the universe is constantly learning. So there's constant new information occurring everywhere all the time. I know you guys might have questions about this, but we don't have time to get to too many details. However, we'll try to have a question and answer session at the end of the day today. Is that good? So this, is occurring everywhere. It's this dynamic of the vacuum collapsing, producing this perfect equilibrium in the middle, which describes the spin around it. The reason why I'm telling you all this as well is that when you meditate, when you turn your senses inward, this is where you want to go. You want to go towards stillness. You want to go towards the singularity at the center. More you experience the stillness, stronger the hurricane is going to be around you. Right? Stronger the energy is going to be generated around you. Stronger your field will be. Stiller you can become. You are the shaft of stillness. You are that point of singularity at the center of your existence. That is actually what holds your information. In an infinite universe of scales, from infinitely big to infinitely small, you are the center of the universe. Because if there's infinite amount of scales, every point in the universe is the center. Right? You can't define a center. Every point becomes the center. Now, I'm not saying that just figuratively. I mean it literally. If there's infinitely large sizes of universe, there is a universe out there that you are actually the center of. And it's not this one. Because we know approximately where the center of this universe is. So it has to be a larger one. Much, much, much larger. So, when you meditate, when you incorporate your black hole nature, integrate that universe that you're the center of. Integrate that. It might take a little while. But then realize that that universe that you're the center of is the center of even a larger one. And that one of a larger one, and so on. That is why all points have the information of all other points in it. Because it's all embedded. So as you realize that you are the center of the universe, there's one thing you must not forget. That is that everybody else is the center too. Otherwise, you might have some serious difficulties. So you all learn about crop circle. Crop circles. Now we're going to come into a field of information that might be a little difficult for some people. That is the field of information that says we may not be alone out there. It just happens there might be life elsewhere in this universe. And these other beings elsewhere in this universe might be more advanced than us. You know, these things have been occurring in England for a very long time. And so at one point, a bunch of people that study these things, study crop circles, said, maybe we should, if somebody's trying to talk to us, maybe we should talk back. So they went out there and they stomped around and made big letters. I guess they wrote it in English. They assume they must know English by now. And they wrote, what do we need to know? And the next crop circle that occurred was this one. Now this is exactly the geometry I've been just showing you. What do we need to know? You can see that the way the hay is bent, the way the hay is woven, you can see that it was made so that you get dark, shadow and less dark, reflective surface, so you can see that it's a three-dimensional tetrahedron structure. You don't do that so easily stomping around at night in the middle of the night. It just doesn't happen that way. Never mind how big it is. You can see here, this is 1997 that this happened. I had already described the 64 tetrahedron grid of the structure of space-time when the question was asked, what do we need to know? Imagine that you were an advanced civilization out there and you found a planet like ours. Remember how I was saying that we have a limited amount of time to get off the surface? So this advanced civilization would have got off their surface on time. They survived the whole thing. And, you found a civilization like us. People always say, why don't they just land on the White House lawn and get it over with? Well, in order for that to happen, we would have to stop shooting. Right? Like, imagine you show up with your ship to this planet, that's not so advanced, and you tune in to their little, satellite feed of CNN, right? And you're listening to the news, and you're going, oh my God, what are they doing to each other, right? And then you turn to your crew, and you go, okay, who's volunteering to go down there and land on the White House lawn? You'd get the guy who's in the corner. He's like, well, I have an appointment at the dentist on the other side of the galaxy. I'm sorry, I cannot go. So what would you do? Well, if you have advanced technology, doing something like that might not be such a big deal. Right? So you'd find nice fields in modern countries that have good media and everything, and you maybe give them, information to try to help them along. Understand the geometry of space, understand the geometry of the fundamental structure of creation, so maybe you can help them get off the surface on time. So, then 2 weeks later, they were insisting, or a few weeks later, they were insisting on the pattern. They did another one. And this one, they put another piece of information in the middle. And when you look at that new piece of information in the middle, you get a whole new set of information. And guess what it is? It's the same geometry, but going inwards, going towards the vector equilibrium, going towards the collapsing part of the equation. So in 2 crop circles, after the question was asked, what do we need to know? We have, the fundamental principle of the expansion and collapsing function of the structure of the vacuum. For somebody like me that was doing that kind of research, you can imagine that I was ecstatic. I was jumping around when I found this. Jumping around in my van, from the outside must have looked bizarre. What's happening in that van, And so, it happens as well that if you put the octahedron structure on top of this, it matches nicely. And then other crop circles occurred. Look at that. That's a perfect 64 tetrahedron grid. You'd think they're trying to tell us something. So, there's much more on the crop circle thing. And actually, there's crop circles. There's one crop circle that's very impressive. It's a reply to the Arecibo message that we sent in 1972, I believe, from the largest telescope radio telescope on Earth at the time, Arecibo. And, Carl Sagan and a bunch of other scientists put this message together that it's like a time card, it's like a binary code that says we're made like this, and we have like this table of elements and all this. And this crop circle showed up, anyway, near a radio telescope in England, with the reply. But if you get my DVD, it's on my DVD. It really helps us when you buy DVDs because all of our research is done in non-profit mode, and actually I'm not sponsored by any other people than the people themselves, this is for the people, by the people. And the foundation is doing the best it can to continue to do research and to continue to get the help of other physicists and so on. And so, everything you can do to help us is very, very important. We're going to start a member section to our website now so that you can participate every month and you get newsletters and you get archives of our phone calls. I do a phone call every month that you can participate in and you can ask questions and so on. And so you'll have access to archives, so please help us. But, you know, these pyramids that were found all around the world, they seem to have a connection to this knowledge about the geometry, to this knowledge about the structure of space-time. And the pyramids themselves represent something very amazing, very remarkable. That is, they cannot easily be explained with conventional means. Right? It doesn't work out. It really doesn't. When you try to do the vine pulling, slave guys with like logs and everything, there's a whole bunch of problems that happens. It was a good idea in the 1800s when the English archaeologists got there, but when you do the math, it doesn't work. It really doesn't. Right? First of all, if they were rolling all these stones on big logs, when you go there and you check it out, you're in the middle of a desert. No logs. No trees. Right? Where did all these logs come from? Right? And then, Grand Pyramid of Giza, right? 2,300,000 stone. All right? 2,300,000 stone. And when they were finished placing them, so it's not just a problem of carrying the stones, when they were finished placing them, the apex of the pyramid is 1/4 of an inch off center from the 13-acre base. 13 acres, okay? The point 5,000 years later is like almost perfectly in the middle. After placing 2,300,000 stones. Right? Now, that doesn't happen with farmers. It just doesn't. Actually, if you had all the means in the world, all the engineering in the world, all the money in the world, with our current technology, we can't do that. Because you have to divide 1/4 of an inch by 2,300,000 stone to get the accuracy of placement. Okay? And those guys, they didn't have walkie-talkie. So imagine the dude that's on the first level, right? They're making the first level. Now they gotta have this thing like perfect, right? Because if they're off like a teeny bit on the first level, then you forget it, right? So like the guy's on the first level is on one corner, and there's the slave over there on the other corner. He's putting a rock down, and like the guy's like he's eyeing it. Yeah, right. Okay, you're a 1/4 of a micron off. What's wrong with you? You didn't sleep enough. What's wrong with those slaves? It's an amazing feat of engineering. Never mind that when they were done, then the faces of the pyramid is aligned to the north, like very high level of accuracy. It's not like you can build it and then like pick it up, and kind of line it up. You got to calculate all that ahead of time. It's amazing. And it doesn't happen with a bunch of slaves pulling on vine ropes. And you know what? Finally, there's more and more archaeologists that are saying, well, yeah, there is issues. Thank you. One of the issues is that the Egyptians loved to write at the time. They wrote everywhere, in all of the temples, in all of the tombs. They put hieroglyphs everywhere, telling us about everything, what they ate, how they went this, how they did that, everything, how they made love, everything. No details were spared, right? For some reason, supposedly these pharaohs built these pyramids to bury themselves in it. Right? Well, in all of Egypt, there's nowhere where it says, oh, by the way, on our spare time, we build the pyramids. What, they forgot to mention it? They built the most amazing building, the largest feat ever done, and they forgot to mention it? There's no at the entrance like, this was Pharaoh so-and-so, and we built this to bury me in it. The other thing is, all the archaeologists assume that pyramids were built to bury pharaohs. However, most of the pyramid, actually, all of the pharaohs were not found in pyramids. The mummies were not found in pyramids. They were found in underground caves in the Valley of the King, which is not where the pyramids are. Many pyramids were sealed completely. It was very difficult to find the entrance. They had to dynamite themselves in or, mine the pyramid to get in. And they would hope that they fall into one of the passages and then backtrack to find the entrance. Because typically the entrance was plugged with 20-ton boulders that were perfectly fitted so you couldn't tell. And so they would do that, get in the pyramid, get to the sarcophagus. Typically the sarcophagus would have a lid of a 20-ton that was sealed. And they would open that lid, and they wouldn't find anything in there. What was their conclusion in their report? Tomb robbers. Tomb robbers got there before them. They opened the 20-ton block, got in there, opened the sarcophagus, remove all the stuff in it, right? Because they really love old bones. And then, put everything back in and perfectly reseal everything so nobody's, they had nothing else to do. So, pyramids were used for other purposes. In fact, there's a book I really like. I don't typically recommend esoteric book, but that book, because of the research I've done in laboratory with some of the technology I've built, I believe is quite accurate. It was a book of a remembrance that a young woman had at the time. And it's called Initiation by Elizabeth Heisch. And I think it's a very important book because there's teachings in there. It talks about, she remembered a lifetime where she was being initiated in the pyramids. And she's the only other person at the time that I came across that had recognized that this object called the Ark of the Covenant that's in the Bible was actually inside the pyramid and was the power source of it. So, there's other monuments in Egypt that are very mysterious. The Sphinx. Most people think that the Sphinx is built. It's not built, it's carved. You'll see blocks on the Sphinx, but those are repaired. The Sphinx was actually carved directly out of the bedstone, in the Giza Plateau. And, if you were commissioned to build the Sphinx, if somebody asked you, go and build me a Sphinx in the Giza Plateau, you would go over there and you would carve it, right? If you were to carve it, you would have to remove blocks around the Sphinx to free it so that you could carve the body. When you remove those blocks, what size blocks do you think you would remove? You'd probably remove 100-pound block, 500-pound blocks, even 1,000-pound block. But you wouldn't remove huge blocks. Well, in this case, the Egyptian, or whoever did this, did not remove small blocks. They removed huge blocks. Okay? They're 200-ton blocks. 200-ton blocks. They're very large. They're removed right out of the enclosure, right out of around the Sphinx. Pulled out. Not only are they 200-ton block, but they're stacked on top of each other to make the Valley Temple in front of the Sphinx. So not only they remove 200-ton blocks, but they were stacking them. 200-ton is barely what we can lift with the largest land crane on earth today. It's about 200 tons. It's big, very large cranes. And these cranes, they don't roll around the desert with 200 tons. Okay? They pick up these parts, they turn, and they drop them. They don't go around the desert. Okay? Now, if you look at the enclosure of the Sphinx, there's actually water erosion there. And the excellent work of researchers such as Dr. Shaw and Graham Hancock, but John Anthony West showed that this is actually water erosion. And water erosion of this kind could not have happened in Egypt since 10 to 12,000 years ago. So now you don't have 5,000 years ago Egyptian going around with 200-ton blocks. You have people going around with 200-ton blocks 10 to 12,000 years ago. Now that's a problem, because we were supposed to be, barely out of caves at the time. So forget about carving the Sphinx. Why am I telling you all this? Well, because it's important to realize that our origins might be a little different than what we have been told. And why would it be important to understand our origins? Because if our origins are a little bit different than what we've been told, maybe in that set of information, This is very important information for us today.